So the first equation described how a static electric charge generates an electric field. And the second, that magnetic poles always come in pairs. The third equation describes how a changing magnetic field generates an electric field. And the fourth equation, that an electric current surrounds itself with a magnetic field. But Maxwell realised there was something missing.
Maxwell's genius was to realise that each of these equations is fine until you put them together. And then he realised something was missing, and it was in this final equation. He said, there has to be another term. And what this extra piece says is if an electric field is changing, it will surround itself with a magnetic field.
Right.
Which is like the sort of mirror of this equation, which says if a magnetic field is changing, it will surround itself with an electric field. So just take these two together and just think about it for a second. If I've got a magnetic field changing, it surrounds itself with an electric. Yeah. If the electric is changing, it surrounds itself with a magnetic. And if that is changing, it will surround itself again with an electric, and so on. Faraday to Maxwell, electric to magnetic, back and forth, back and forth.
So there's a coupling, basically, between the two.
Maxwell's equations were saying that electric and magnetic fields were inextricably linked. Changes in one created changes in the other. It helped explain so much. When Faraday moved his magnet, he changed the position of the magnetic field, and this triggered an electric field which caused electricity to flow through the wire. And when electricity passed through a wire, it wrapped a magnetic field around it, causing the compass needle to move. Using pure maths, Maxwell had unified electricity and magnetism, and shown there were two aspects of the same thing: a single electromagnetic field.